Unit 5, Part 5, I was explaining the correct understanding of what has been achieved or shown when a counterexample is found. Right? What's been shown is that the argument form is invalid. Right? When you have any particular row, just any one row will do. You could have 16 or 32 base columns, and they could all be fine except there's one row where the premises are true and the conclusion false. The correct conclusion is that the argument form is invalid, and that means every single substitution instance of that argument form is invalid. Right? That's the true view, right? And that follows from our understanding whereby, from Unit 1, a particular argument is valid if and only if its form is valid, and its form is valid if and only if it has no substitution instances where the premises are true and the conclusion false. Okay, so that's the correct answer. And I was warning you away from the false understanding, which is to say something like, oh yes, it's invalid on this substitution instance. It's invalid where P is true and P is false and Q is true, but it's valid everywhere else. No, it's not, right? I'm saying our understanding of the modal notions, necessity and possibility, a valid argument is one where it's necessarily the case if the premises are true and the conclusion is also true. Valid argument is one where it's not possible for the premises to be true and the conclusion to be false. Right. That was made. We got a grasp on those modal notions through the notion of form, and if a form has a counterexample, that means the necessity doesn't hold. Right. If any form has a counterexample, then that's like saying that it is possible for the premises to be true and the conclusion false, even when the premises are true and the conclusion is true, right? So that means the necessity, so the correct view, taking back to the truth table, the correct view of what is implied by having one counterexample in this row is that the necessity constituting validity, right, or the impossibility of the premises being true and the conclusion false, that necessity, let's go with the necessity, that necessity doesn't hold here or here or here or here or here or here or any of the other substitution instances. Right? The necessity is lost through the one counterexample. Catchphrase, one counterexample spoils the whole argument form. Okay, so that's the theory. In terms of what you answer on the exam, so when you point to the row, which would be the counterexample, right, the one that fits this, that you've detected as the terminator that you are, true, true, false, you write CE, right, counterexample, say, this argument form has a counterexample, therefore this argument form is invalid, right? What was the question? Use the full truth table method to show the following argument form is invalid, and that's what you've done. Here's the counterexample, computed all the truth tables, this one's invalid. Okay, let me do this one for you, 1D, a slight more complication. Before I forget, this one's simpler than the one Klenk runs through in the book, but when she runs through on page 80 especially, so section 1 of Unit 5 is on base columns, section 2 is the truth table test for validity. I encourage you, it starts on 79, to take this 1, 2, 3, 4, 5-step procedure to heart. Right, I'm running through it over and over again, but see that all right? Yep, page 79. Right, list the premises in conclusion horizontally at the top of the. Right, read that. That's what I'm going to be doing here again. But on page 80, when she runs through an example, it's another example of a page you might have to read 10 times. And you have to make sure that you follow her reasoning at each step, right? Actually, 80, also 82 especially, I think, right? Yes. Yeah, and 82, the other example where she gives you, so here's 82. So the 1, 2, 3 she has down the bottom here, that is the order in which the, columns appear. As I said, she wants you to do it column by column. It's easy to do it column by column, formula by formula, as it were, as opposed to row by row. Row by row is not as efficient, and you will be pressed for time in the exam. but she's calculating the sub-formulas of the overall formula before she does the truth table column for the overall formula. I'm going to do it on the second premise here, because it has these two levels of complexity. She has a much more complicated one there that she works through. Make sure you follow every step of how she works through it. Okay, so the first thing to notice, so remember you also have to move the formulas into a column, or set up a column. You're given, the thing you're given is just test this argument form, this, comma, and then therefore that. That's the conclusion. So you draw up these, put them into columns, and now look what you do. This is important too. You don't know without checking how many rows your truth table will have. How many rows your truth table has depends on how many sentential variables there are. Sentential variables are the P's, the Q's, the R's. Okay, so you have to look and you have to count them. So I go across, I go P, that's my first one, I've got one P. Q, I've got a Q. Right, are there going to be any more? P again. Q, okay, I've already got those, P and Q. And here, there's just P and Q. There's no R. Okay, so there's only two sentential variables. Now what you do is you list those to the left in alphabetical order, right? So we have P and Q. Now I'm constructing my base columns, right? And I do that, and you have to do it this way, and I will mark you wrong, even if somehow you get all the combinations, but you don't do it in exactly this order, because damned if I'm marking 80 papers with different truth tables all over the place, right? Do it like this, systematically like this. Start at the right moment. Okay, you've already determined there's going to be 4 rows, right? Because 2 sentential variables, 4 rows exhausts all the possible combinations. Of course, if you have 3 sentential variables, you need how many? 8 rows to exhaust all the possible combinations. If you have P, Q, and R, right, it's going to be everything we put down, which is going to be the same as base columns over here. All that when, say, it would go P, Q, R, but all that when R is true and all that when R is false. Except, of course, the R would be the true, false, true, false, true, false, true, false. The Q would be true, true, false, false, true, true, false, false, and the P would be true, 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 false, 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 false. Because the order you have to do it is start with the rightmost one and go true, false, which is what you do when there's 4 of them, like there is here. If there were 3 sentential variables, so you have 8 rows, you'd be going true, false, true, false, true, false, true, false. Right? But here you've just got 4, true, false, true, false. Move to the left and double. All right, move to the left and double. That's double the number of trues and falses. So double goes true, true, false, false. Right? If that was Q and R, right? If it was P, Q, R, so I'd have this column for R, I have this column for Q, and my P, move to the left and double. True, 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 false, 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 false. Right? That's what move to the left and double. Double the number of trues and false. I went from 1 to 2. If it was 3 columns, I'd go to 4 trues and then 4 falses. Okay, she explains this clearly in the book. Make sure you follow that method. Okay, and now I'm going to calculate the truth values of the sentence forms, right, for the premise and conclusion. This is premise 1, premise 2. Okay, so this true, false, true, true, it is simply the truth table for the hook, right? Now look here, this is where something equivalent to the 1, 2, 3 that Klenk has on 82 and I think 80 when she works through examples. Right? The order in which you hear your knowledge of the structure or order of composition of statement forms comes into play, right? It's P or not Q. What is the form of that statement? You have to ask, you have to be able to see what the form of that statement is. Is it a negation? No. The major operator is the wedge. It is a disjunction. It disjoins P and what? And not Q. Okay, so when I'm becoming a terminator, right, at the end of this, I shall continue in the next part.